Welcome to our first flipped classroom lecture, and we're going to go over the introduction to the periodic table. So really it's just like the anatomy of the periodic table, and most of this should be a review to you, so we're going to go over it quickly. What I want you to come to class knowing, okay? I would like for you to know these 5 bullet points. So I want you to be able to describe how the periodic table is arranged today. I want you to be able to tell me the similarities and differences between the groups and periods on a periodic table. I want you to be able to tell me what the common groups are called, and be able to tell me the properties of metals and nonmetals, and describe what a metalloid is. So most of this is just vocabulary, but we are going to learn a few people and a few pieces of the periodic table, which you probably already know. So the first scientist we're going to learn about is Dmitry Mendeleev, and he is credited to be the first person to kind of start this periodic table. He didn't have much family once he was accepted into the university, so he kind of got a little obsessed over the periodic table, and he was able to kind of start it. So here's what his periodic table looked like. You notice there's no noble gases because many of the elements were based on their reactivity, and as you know, noble gases aren't very reactive, if they're reactive at all. So you'll notice that if you can look at the slide, there's many dashes. So he made this first periodic table before all of the elements were even discovered. So that was pretty neat. I mean, could you imagine making this periodic table with some elements you didn't even know existed? So he was able to predict elements that once they were discovered, he was able to tell you how many protons they had, or what its atomic weight was, kind of how it might behave. So that was pretty interesting that he came up with it. And then obviously this is not what it looks like in the class, right? So this guy is credited for what the periodic table looks like today. Instead of arranging the elements by atomic mass, he arranged them by atomic number. And this is what we're using today. Okay, so the periodic law, it just states that when the elements are arranged in the order of increasing atomic number, their physical and chemical properties create a pattern. So there's a pattern of their physical and chemical properties if you arrange them by their atomic number. And we'll learn the patterns kind of throughout this lesson. Not this lesson, but this unit, sorry. So the anatomy of the periodic table, so the periods and groups. So if you're looking at the main screen, the periods, they kind of go across horizontally. So like this whole line is considered the period, okay? So going across this way, those are periods. And then the groups are the vertical columns. So for example, this going down, that would be considered a group, okay? So whenever I say, I won't really refer to them as rows and columns, I'll refer to them as periods and groups. All right, so elements in the same group have similar properties. So basically, elements in the same group, like this, they will all have similar properties. So what that means is they kind of react similarly. So all of these guys going down will react similarly to each other. Same with these. These elements will all react similarly to each other. And for example, these elements on the left in group 1, they they are very highly reactive with water. So when you expose the element to water, they react violently to it. And the further you go down, the more violent they get. All right. The elements in the same period, they don't have similar properties. So if we're going across this period, obviously if they all have similar properties going down, it's not going to be similar properties going across. So these elements going across, they all have the same energy level. So what that means, so to have the same energy level, what that would mean is, remember when we had this, I'm just going to draw a generic element. this would be a nucleus, right? And I'm drawing the planetary model. And then we have 1 energy level and 2 energy levels, 3. So each of these circles that I drew around the nucleus, each of those circles are going to be considered an energy level. Okay, and this is where you'll find electrons. You have 2 electrons in the first one, and then you can have up to 8 in the second one, okay? And then we're going to say 8 in the third one, but in a couple of weeks, you're going to know that that's actually a lie. All right, so moving on. I'm sorry, so hold on, let me not move on. Okay, so energy level. So energy level 1, this is energy level 1. That pertains to this period right here, okay? Energy level 2. So energy level 2, this was 1. This will be 3, okay? So energy level 1, that's 2. There's 2 elements in there. 2 electrons, okay? Energy level 3, there's 2, there's 8 electrons here. 1, 2, 3, 4, 5, 6, 7, 8. So this whole period, and these are not electrons, but just whatever. There's 8 here. So there's 8 dots here representing electrons. And we'll learn more about that with electron configuration. And then so on and so on. We move ahead. So these actually can get really, really big with a lot of electrons. If you notice, we can get up to 82, even more, 103, if we're drawing these, and it can get kind of crazy. You won't have a crazy one on your assessments. I'll probably keep it in the d orbital or p orbital, probably not too much in the f orbital. But you will know how to do that. All right, so moving on. Blocks on the periodic table. So, let me get another one. Okay, so blocks on the periodic table. This is critical that you know this because I will just refer to them as if you know them. So the S&P block. So this is a block, okay? This whole chunk of the periodic table, we consider that the S block, okay? And then the P block, this is considered the P block right here. Keep in mind helium kind of goes over here, okay? So that's helium. This will be considered the P block, okay? So those are representative elements. That's what we name them. And then in the middle, the D block. So all of these transition metals right here, they are part of the D block, okay? These are transition metals. And then down here, we have the F block, okay? And we name them according to the orbitals. You're going to learn again in electron configuration unit about orbitals. And they're going to be, there's an S orbital, P orbital, D orbital, F orbital. You should have learned that when you went on your gallery walk, your peer review gallery walk in the project that we just finished on Friday. But that doesn't mean you memorized it. I'm just saying you're going to see these letters often in this class. Okay, so you'll notice that the slide is now illustrating this. So the S block again on the left and the P block on the right, the D block in the middle, and F block at the bottom. So we also have names for them. So the first group here, those are called alkaline metals. And then the second group, alkaline earth metals. I'm not going to write on here. And then transition metals. And the next 4 you can label, but we don't really say these families in class very often, if at all. I will just call these by their group numbers. So for example, this is group number 13, 14, 15. I'll usually just call these 4 by their group numbers, and then these I will call halogens. And the last one is, these are noble gases. Most of you know these. And I don't know if I changed my PowerPoint. Yay, I did. I had these labeled as halogens, and that was completely wrong. F block, we're going to consider those intertransition metals. Okay, this whole block kind of fits right here. All right, properties of metals and nonmetals. This is basically just a comparison of the two. Most of them are common sense. Metals are considered shiny, malleable, and ductile. Those means that we can just kind of mold them into what we need, whether we need wire or some type of car or something. Those metals kind of tend to be moldable. And they are good conductors of electricity and heat. We don't really talk about that in chemistry. You will talk about it in physics, but we're not going to really discuss that here. We do thermochemistry, but it really has nothing to do with electricity. Okay, and they're located to the left of the staircase. So here's the staircase we're talking about right here. You just draw a staircase right there. And then all of these are considered metals, okay? These guys too. So those are to the left of that staircase. So this is the staircase I'll show you in the next slide, actually 2 slides. And then the nonmetals, they're dull, they're brittle, they're poor conductors. So they do not conduct electricity. And again, we don't really dwell on that in chemistry, but you will in physics. And nonmetals are considered to be located on the right side of the periodic table. All of those are nonmetals. All right, metalloids. So metalloids touch the staircase. So basically, these are metalloids. I'll show you in the next slide. But they kind of touch the staircase. Aluminum is definitely a metal. We don't consider that a metalloid. And metalloids are good semiconductors. They were a huge, they're a huge part of electricity and being able to deliver electricity. So like silicon, and they're kind of a hybrid between a metal and a non-metal. They have both properties of metals and non-metals, and even the exact list of elements kind of vary from scientist to scientist. And that's really because, remember at the beginning of the year, guys, I told you that the periodic table is not black and white. It's not just metals and non-metals and then these things called metalloids. It's this gradual change from a very metallic to non-metals. So just keep that in mind whenever I'm saying that some of these are considered, but you might see it in another periodic table, extras highlighted, and then maybe you see less highlighted as a metalloid. So just keep that in mind when you see some differences in what I'm saying. It's not because I'm wrong. It's not because the other scientist is wrong. It's just because this is a gradual change, and it's not like, okay, it for sure stops here. Okay, moving on. So here's your staircase, okay, right there. The staircase, everything above that staircase, so all of these from boron all the way down, those are metalloids. So they have kind of properties of metals and nonmetals. So all of these, and then GE, antimony, and PO, those are also metalloids. Aluminum is not. We're going to for sure consider that a metal. That's it. Make sure you come to class knowing those 5 bullet points.